Hi, today we will be discussing the key factors that affect water's bulk property scale of rate of evaporation, more specifically at a molecular scale that could be affecting its evaporation rate and time and the temperature required to do so. As seen here, water's chemical formula is H2O, meaning a single water molecule is composed of 2 hydrogen atoms and 1 oxygen atom. As shown in this model, this is the Lewis structure of water, indicating that this molecule forms a polar covalent bond. As for why covalent, this is due to oxygen being in group 6 and hydrogen being in group 1, hence being both nonmetals, which is why one can call this bond a covalent bond. Oxygen's electronegativity is 3.5, whereas hydrogen's is 2.1. Whereas hydrogen is 2.1, which makes the total difference of electronegativity being 1.4, which is evidently higher than 0.5. Hence, this molecule could be considered as polar. In other words, this bond is seen as polar because, as seen in this model, one side is slightly more positive and the other is slightly more negative, hence the S- and the S+. This is indicated by the lower side containing 2 hydrogen atoms with weak electronegativity, and the upper side with 1 oxygen atom with a stronger electronegativity. Additionally, the reason for which this could be considered polar is because of the 2 pair of free electrons, as shown right here, that are above the oxygen atom, making the upper and lower side unequal, with the upper side attracting the electrons more strongly, hence being negatively charged with the addition of its 2 pairs of free electrons, and the lower side having little attraction due to its lower electronegativity, hence a lower force of attraction to its electrons. Finally, the way the evaporation rate is affected by polarity is determined by the fact that more polar molecules will stick together more and will evaporate more slowly due to their strong force of attraction, whereas less polar molecules should evaporate faster because they are not as attracted to each other. Now, this model is a perfect example because, as seen on the image on the left, the atoms and molecules in this picture show that they are very distant and far apart. Very close and bind it together, which means they have a stronger force of attraction within each other, hence a stronger electronegativity, hence being polar molecules, which is why they have a stronger force of attraction and a slower evaporation rate. Whereas the image on the right could be indicated that the atoms are very far apart, meaning they have a weaker force of attraction, hence a faster rate of evaporation due to the fact that the atoms are not very binded together, which is why it would be far easier to convert their liquid form into their evaporated form, or gas form as one might say. Which is why in conclusion, one could conclude through all these facts that water would be a liquid that could evaporate very slowly due to its high polarity between its oxygen and hydrogen atoms. Thank you.